Hello all. In this video, I'm going to walk through what is an open lake house. Okay, so if you look at this picture, we have a data lake and it has data coming from different sources. And then on top of that, we have a small warehouse or house. And then, and it is fully organized, well curated. But here, the data is coming from, different formats and different sources, different structure. And so if we combine this data lake with warehouse, we're going to call as open lake house. Okay. So let me walk through. First, data lake. Data lake is a centralized repository that stores structured, semi-structured, and unstructured data at any scale. It allows you to store data in its raw format until it's ready to be processed and analyzed. So think about Hadoop file system, right? And big data world. So you write once, read many times. And then, different variety of data and structured and unstructured, but we store as is. So basically, in a simplistic term, data lake is a garbage lake. You can put any variety of data. It can store large volume of diverse data, supports wide variety of data formats, and flexible for data science and machine learning, and then, a lot of batch processing. What is missing is lack of strong data management features. Governance and ACID features, concurrency, consistency, and then, streaming. It's preferably good for batch, but at the same time, you write once, read many times. And if you want to modify the data, you have to delete the file and add the files. That's how the data lake. This has been, we implement in Hadoop file system. Then they introduce a Delta Lake, which is basically on top of your data lake, where we can implement ACID. So, we can update concurrency, atomicity, consistency, isolation, durability. So if you introduce with Spark and Iceberg and or Delta, then you can create a Delta Lake. In the Delta Lake is basically on top of existing your data lake files. You're not rewriting anything, and you're just converting your data lake to Delta Lake. Okay. And so definitely it allows you, since we're adding a Iceberg on top of existing data lake, it allows you versioning, time travel, schema enforcement, the schema enforcement, because the schema change is done at the meta layer. And that's why we are learning about Iceberg, where Iceberg allows you to alter your database schema without impacting your data files. And also it supports both batch and streaming data process. Now we learn the data lake is Hadoop file system, write once, read many times. Delta lake, where we allow ACID and where we can do streaming, combined streaming and batch processing. Now the concept of open lake house. A open lake house is a new data architecture that combines the best features of data lake and data warehouses. So what is a data warehouse? Structured data format, curated, governed. And then you have a data lake, which allows you massive file system, massive data. Then if you combine your data warehouse features, which allows you ACID, transactions and streaming and batch, what we learn in Delta Lake. And if you implement data warehouse features and on top of your data lake, right here, very important, data lakes and data warehouses, and then, we can implement a open lake house. The open lake house is basically a open table format, and any file system, S3, HDFS, any cloud, and allows the transactionality and governance, and there is no vendor lock-in, right? Because it's open table format. Iceberg is an open table format. And then, as I said, any cloud and many engines, Spark, Impala, Flink, and Snowflake, Databricks, Dreamio, Trinio, many engines can read the same format. And then there is no vendor lock-in, then no cloud lock-in. So, and then it also allows both batch and real time on a single platform. That is important. It allows to manage both. So that's where the Open Lakehouse, Open Data Lakehouse or Open Lakehouse. Okay. Why Open Lakehouse is more advantageous? Unified architecture. It bridges the gap between data lakes and data warehouses by allowing businesses to manage structured and unstructured data efficiently in one place. So you can have a data warehouse features, you can have a time travel features, you have a structured, semi-structured, unstructured data in same place, and it allows ACID transactions, open standards, no vendor lock-in, and also vendor support, many vendor support, and then many engines, any cloud, and common table format. So it allows ACID transaction, optimized performance, 10x we will see 10x performance and Iceberg file system as compared to data lake tables like Hive. And it's cheaper, right? You're running on open format and 10x performance. That's where definitely makes your application development cheaper. And then you can combine governance also. And summary, Data Lake offer flexibility and Delta Lake provides transactional reliability. Open Lakehouse combines these advantages while adding interportability, performance, and governance on top of open standards. That is the key, the open standards. Okay. For that reason, we are learning about Open Lakehouse. Now, Cloudera, Dreamio, then the EMR, all those tools, they support Open Lakehouse, and tools like Snowflake supports Iceberg. Then there are different catalogs and engines. The engines in the sense Snowflake runs the Iceberg in one way. And then when you go to Databricks, then you can create a Delta table and also Iceberg table combination. And so the key here is openness. You can build a data lake and Delta Lake combination as a warehouse, and then we create a Open Lakehouse. Open Lakehouse is your data lake, massive data, write once, read many times, convert those file system into Delta Lake with the warehouse features we call as a Open Lakehouse. Open Lakehouse key features are when no vendor locking, common table format, any cloud or any file system like S3, HDFS, ADLS, GCP file systems. And then optimized performance, you can use different the engines where we have its own catalyst, something like that. And then you can also add advantage indexing coming soon in the Iceberg, and then statistics you can build, and then hidden partitions. So, and schema evolution. And you can change the schema without impacting your downstream, upstream applications. Partition evolution and hidden partitions. And you can alter the partition on the fly. You can make the partition change without impacting your upstream, downstream applications. But in the data lake where we use Hive, if you want to alter the partition key, it's not easy. You have to go through many steps. And then every time when you want to change the partition key, you have to change your end user applications. So Open Lakehouse is a new format and new standard, and all tools, right, moving towards Open Lakehouse. So think about, you have a data lake, variety of data, and you built on top of a data warehouse, allows ACID transactionality, openness, no vendor locking, a lot of vendor support. That's where the Open Lakehouse. So this class or this book is meant for Open Lakehouse recipes, and that's what we're going to learn about it. So we completed configurations, what we need for a EC2 instance. We completed your Spark configurations, and then what we're going to do is we discussed about open lakehouse. Now we're going to build Hive tables. Then we're going to build Iceberg tables. And then while we're building the Hive table, we'll look at the Hive architecture. Then we're going to build an Iceberg table. Then we will compare with Hive architecture with Iceberg architecture. Then we deep dive into Iceberg features. The partitions, time travel, branching, tagging. Then how to migrate. Then we do it, how to create Iceberg table in Snowflake, how to create Iceberg table connecting to Polaris, EMR, S3, Cloudera, Databricks, and all those tools. So it is a massive recipes book, and we're going to add one video at a time. So keep learning it. This is the industry data engineering, what they are looking at. Okay, thank you.